All right, guys, so we're gonna find the KEQ, the equilibrium constant for this question. So I have at 900 Kelvin, a 4.00 liter reaction vessel originally contained 0.60 moles of SO3. So I know that originally I had 0.600 moles of SO3 in a 4.0 liter reaction vessel. And then at equilibrium, we had 0.12 moles of SO2. So then at equilibrium, I had this much of O2. So the first thing I'm going to do is that I'm going to make an ice table. So I have my initial, my change, and my equilibrium. Well, I know that originally I had 0.60 moles of SO3 in a 4.0 liter reaction vessel. And I know also that in my equilibrium constant, I can only have concentrations. I can't have moles or just liters. I have to have the concentration. And we also know that concentration is just your moles divided by your liters. And then the question, you have your moles, you have your liters, so if you divide the two, you'll get the concentration of SO3. And that's what I'm going to do in my calculator. So I'm trying to find the concentration of SO3, and it's going to be moles, so 0.60 moles of SO3. You don't have to write it out again, but because you wrote it here, and then divided by 4.00 liters. So, and then that's going to give me 0.60 divided by 4 is 0.15 molar. So that's my concentration of SO3, and that's originally. So that goes under my initial box for SO3, 0.15 molar. That's what I know. And I know initially for any reaction, you can't have any products. When the reaction is at time 0, for any reaction, you're not going to have any products. So I'm going to write 0 moles of this and 0 moles of this. Okay. Now the next part says at equilibrium. So now I'm looking at this column right here. There's 0.12 moles of O2. Okay, same thing. I need to know my concentration. So concentration is just moles divided by liters. So I'm just going to go 0.12 divided by 4 to get my concentration of O2, which is equal to 0.03 molar. And that's at equilibrium, so I'm going to write it here, 0.03 molar of O2 at equilibrium. Okay, now I know all that. For my change, this is what we're going to do. I know that SO3 is being used up because it's a reactant. So as time goes on, it's going to decrease. So I'm going to put a negative sign right there. SO2 is a product, so over time, it's going to increase. And if it's going to increase, we're going to put a plus. Same with O2. O2 is a product, so as time goes on, it's going to increase. So I'm going to put another plus there. The next thing I'm going to look at is the coefficients on each of these things. We know that the SO3 is being used up twice as fast compared to the O2. SO2 is being produced twice as fast compared to the O2. So the next thing I'm going to say is, okay, it's going to be twice as fast. So I'm going to put a 2 there. And this is also going to be twice as fast. So I'm going to put a 2 there. Now for my O2, I'm just going to put a 1. Because this is twice as fast and this is also twice as fast. And I know that SO3 is going to decrease by some x value, but I don't know what that value is. So I'm just going to put x by some unknown variable. My SO2 is increasing by some x value, so I'm going to put an x there. My O2 is also increasing by some x value, so I'm going to put an x there. Now the next thing I need to determine is what that x value is, because with that x value, I can determine what each of these things is going to be at equilibrium. So I'm going to take a look at this part right here. So I start off with 0 molar of O2, and I end up with 0.03 molar of O2. Well, if I start from 0 and then I go to 0.03, what am I doing? I'm adding 0.03. That's interesting. And then I know that I'm adding by some x value. And in this case, that x value is just going to be 0.03 molar because that's what I increased by. So now I know my x value, and if I know my x value, I can sub it in into each of these to determine what each of these is going to be in the end. So 2 times 0.03 molar, 2 times 0.03 molar is going to give me 0.06 molar. And for this, it's going to be the same times 2, so it's going to be 0.06 molar. But the thing is, this is plus. This is also plus because since these are being produced, more of it is being made. This one is a negative 0.06 molar because it's a reactant and it's being decreased over time. So if I start off with 0.15 and I decrease it by 0.06 molar, I'm going to put that in my calculator and I'm going to get 0.09 molar. So I'm left with 0.09 molar. For this one, I started off with 0 molar and I added and it's adding 0.06 molar, then you end up with 0.06 molar. So for this reaction to reach equilibrium, 0.09 molars of SO3 was left over, 0.06 molar of SO2 was produced, and 0.03 molar of O2 was produced. Now I know everything in my equilibrium section for this table. And I know that my KEQ deals with everything, deals with the equilibrium part of this table. So the next part I'm going to say is, okay, what does my KEQ include? Like, what is included in my KEQ? So I know my KEQ includes anything that's a gas and anything that's aqueous. So if I look at this chemical reaction, I can see that everything is in a gaseous state. So everything is going to be included in my KEQ. Okay, I know that. Now the next step is, what is my KEQ? We know that the KEQ, it's a capital K, KEQ is equal to your products, so my products, divided by my reactants. So for here, for my products, I have SO2. I'm going to write that out first, SO2. And then I also have O2. But if we remember, we'll see that the coefficients become exponents in our KEQ. So here I have a coefficient of 2. So in my KEQ, that's going to become an exponent. O2 has a coefficient of 1, so my exponent is going to be a 1. For the next part, my reactants, I only have one reactant, so it's SO3. It has a coefficient of 2, so that means that it's going to have an exponent of 2. So for the next part, it's very simple. All I have to do now is sub in those values. So the concentration of SO2 at equilibrium is 0.06 molar squared. You don't have to put in the units because KEQ doesn't have units, but you can put them anyways if you want to. The concentration of O2 at equilibrium is 0.03 molar, and it's all divided by 0.09 molar squared. So lastly, I'm going to put everything into my calculator, and I'll do the numerator first. So 0.06 squared times 0.03 is going to give me 1.08 times 10 to the negative 4. Don't worry about units. And then my denominator is going to be 0.09 times 0.09, which is 0.0081. Now if I just divide both of those, I will get my KEQ to equal 0.01333, and that's continuing on forever. So what we can do is write KEQ equals 0.013, and if we put a little dot on top, it means 3 is continuing on forever. And that's how you find the KEQ of the equilibrium constant.